Hello everyone, we are Group 23. Our project aims to build up a robust identification model using single-channel ECG data. As a byproduct of our research project, we built up our dashboard showcasing all the machine learning aspects that we are using in our project. So as you can see in our dashboard, there are 5 major tabs: ECG purifier, ECG insight and analysis, arrhythmia detection, myocardial infarction detection, and person identification. When we came into ECG purifier, in this page we showcase all the pre-processing filtering techniques that we apply to ECG data. So what you need to do first, you need to browse files and upload the ECG data as a data stream, as a bit stream of your ECG signal. You can see that files are uploading. After that, you can see the visualization of your ECG data. In the right hand side, we showcase all the pre-processing techniques: normalization, baseline removal, low pass filter, notch filter. And you can select anything that you want to apply to your ECG data. And this is the ECG data without applying any pre-processing. And here you can choose option. If you choose normalization, you can see that your ECG data is scaled into 0 to 1, and as well as you can use high pass filter. The high resolutions are removed in your ECG data. Can use low pass filter, and the low ECG signals are removed, and notch filter as well as the baseline removal. And you can scale up and down your ECG data. And when you scroll down, you can see there's a save button here. When you save your ECG data, it is in the system. And then if you want to apply any other ECG data as the same as the previous, you can browse your file and upload. Your previously uploaded ECG data will not be replaced. So you can upload any kind of amount of your ECG data and see the visualization. So here 101 ECG data's visualization is here. So then we move on to the ECG insight and analysis tab. Here you can select ECG data, and you can see that each peaks, P, Q, R, S, T peaks of the ECG data is visualized. These are the identical peaks of ECG data. So you can horizontally scale this ECG data and see clear visualization. Here there is the horizontal scale bar. You can adjust any way you like, and also here you can see the heart rate, the BPM rate of your ECG data, and also you can identify whether your ECG data is irregular or regular. And also you can see that the PQ, QR is ST average time intervals, and for a normal person there's a fixed average for this each interval. So you can see if your time intervals are not in that range, you can see that there's some kind of arrhythmic detection in your ECG data. So that is about this step.
Moving on to the arrhythmia detection section. As you can see, we have classified the beats according to the Association for the Advancement of Medical Instrumentation. Here we have identified the normal beat count and the arrhythmia beats count. The next section is about myocardial infarction detection, which is heart attack. In this ECG signal, there is no myocardial present. Let us take a look at another ECG signal. Here, there is myocardial infarction in this ECG signal. The next section is about person identification. Here I have loaded 2 ECG signals from different people. As you can see, these are from, our model says that these are from the different people. But if we don't have the labels of these 2 ECG signals, like we have the 2 ECG signals, but we doubt whether it is, but we don't know whether these are from the same person or not, we can use this to identify them. This is about the dashboard.
Welcome everyone. Robust ECG-based person identification, revolutionizing biometric identification in healthcare. Cutting-edge research from our team explores the potential of electrocardiogram signals to unlock new frontiers in biometric identification. Why ECG for person identification? Electrocardiogram signals offer a unique inherent biometric signature based on the electrical activity of the heart, gaining an advantage of traditional biometric systems like fingerprints or facial recognition, which are most susceptible to forgeries. So, what are the challenges in ECG-based person identification? While state-of-the-art ECG-based authentication models work well in controlled environments, real-world scenarios present significant challenges that limit their practical adoption, particularly in healthcare settings with mobile monitoring devices. So, what's our approach? Our approach is mainly focusing on tackling noisy ECG signals. Our team has developed innovative machine learning models that can accurately identify individuals from noisy electrocardiogram signals even in real-world scenarios. What's our validation? Validated on standard and noisy ECG datasets. Our model is validated on standard datasets like MIT-BIH arrhythmia database, PTB Diagnostic ECG database, and most importantly, St. Petersburg in-card database. The specialty of St. Petersburg is a noisy dataset with ECGs collected via Holter monitors reflecting real-world noisy scenarios. Our performance highlights of our model. So we could get decent accuracy rates in MIT-BIH, PTB Diagnostic. The most importantly, outperformed sorter models on noisy datasets. Especially, we accepted the challenge St. Petersburg in-card database and we could get an accuracy over 90%. What are the real-world applications of our solution? Our cutting-edge EC-based person identification technology offers transformative solutions for real-world healthcare challenges like hospital security, wearable devices, and practical record security. Why should you choose us? So we are mainly focusing on noisy data, and we are confidently outperforms many noisy ECG real-world scenarios. So it's your choice to choose us. So thank you very much.